go over it. Now the first one, calculate the square root of 15 plus 7, everything to the power of 3. So with that one, you just type it in the way it is on your calculator, the square root of 15 plus 7, you close your brackets, and this is to the power of 3. And it says give your full calculator display. So on my calculator, I have 1,285.4233 and 02. So this one is just testing your ability to use a calculator and then write down exactly what you see. So the next question, number 2, write 0.36 as a common fraction in its simplest form. So here we have 0.36. We want to write it as a fraction. So the first thing is to convert it to fraction form. Whether that's in its simplest form or not is not the issue. First, rewrite it as a fraction. Now 0.36, this is 36 over 100. And then what you do over here is you can now simplify it. So you look for numbers that you can divide in the numerator as well as the denominator. Now 36 has a factor of 4, which is also a factor of 100. So you can say 36 and divide this by 4, and then also divide the denominator by 4. So 4 goes into 36 and also into 100. So it is the highest common factor of 36 and 100. So this will give us 9 over 25. So our answer is 9 over 25. Then 3 over 5 as a percentage, we just say 3 over 5, then you multiply by 100%. So this is equal to 60%. So this you can just do on your calculator. Right, from the list, this is the list, 8, 13, 49, 77, and 109. Write down a prime number. So remember, a prime number, this is a number that does not have any other factors except 1 and the number itself. So the prime number that we have over here is 13. So I would write that down. 13 is a prime number because it has only 2 factors, that is 1 and itself. And a square number, this is a number that you get when you multiply another number by itself. So 49 is 7 times 7, so our square number is 49. Next one, number 4, we have 5.2 times 10 to the power of negative 4 as an ordinary number. So times 10 to the power of negative 4. This one, you can write it, this is 5.2. And then 10 to the power of negative 4, this is 1 over 10 to the power of negative 4. That means it must have 4 zeros. Okay, so here we're actually saying 5.2 divided by 10,000. Okay, and since we're dividing by 10,000, this decimal point is going to move 4 spaces to the left. So this will be If I write it like this, let me just write it 5.2. So we say the decimal is going to move 4 spaces. So 1, 2, 3, 4. So the decimal will be over here. These spaces will replace them with zeros, and then there's a 0 over there. So our answer is 0.00052. Okay, number 5, arrange the following numbers in order of size. The smallest one first. Now, when these fractions are written like this, it's not so easy to tell which one is big or small because all of their denominators are different. So what you can do is you can rewrite all the fractions so that the denominators are the same, and then you just compare the numerators, and then that will tell you which one is bigger or which one is the biggest and which one is the smallest, and so on. Now here you have the numbers 5, 30, and 12. You can look for the highest common, sorry, not the highest common factor, the lowest common multiple rather of these 3 numbers, and then rewrite the fractions where the denominator is the lowest common multiple. So if I look at 5, 30, and 12, the lowest common multiple is 60. So I'm going to rewrite each of these fractions as fractions over 60. So we start with 3 over 5. So 3 over 5. So what I want to do is write this as a fraction over 60. So I ask myself, what do I need to multiply 5 by in order to make it 60? And the answer is I need to multiply it by 12. So I multiply the denominator by 12. I also multiply the numerator by 12. So 3 times 12, that is equal to 36. So this is equal to 36 over 60. Then 17 over 30, I do the same thing. I want to rewrite this as something over 60. So to 30 to become 60, you need to multiply this by 2. 17, you need to multiply by 2. So 30 times 2 is 60. 17 times 2 is 34. So my second fraction is 34 over 60. And already you can see that this fraction, 3 over 5, is greater than 17 over 30. And then our last fraction, 7 over 12, we want to rewrite this as something over 60. So ask yourself, this 12, what do I need to multiply it by in order to make it 60? And the answer is you need to multiply by 5. Multiply this by 5, multiply the numerator also by 5. 12 times 5 is 60, 7 times 5 is 35. So my 3 fractions, if I write them in the order that they are given here, 3 over 5, this is 36 over 60. 17 over 30, this is 34 over 60. And then 7 over 12, this is 35 over 60. And now because the denominators are all the same, all I need to do is compare the numerators. Now we want to start with the smallest. You must write the smallest one first. So you look for the smallest numerator, and that's this one, 34 over 60. But you don't write it the way I have it over here. You write it the way it is given. So this is 17 over 30. So this is our smallest one. The next one is 35 over 60. That's 7 over 12. And then lastly, we have 3 over 5. Question 6, we have to express 360 as a product of its prime factors. So 380. Now, if you're not sure, start with the smallest prime factors. That's 2, 3, and 5. So you have 380. First, you divide it by 2. You get 190. So that means I can write 380. This is 2 times 190. Then you should check this 2 is a prime number. this 190, if it's prime, then you have written it as a product of its prime factors. But 190 is not prime, so you look for another prime number that you can divide 190, that can divide 190. So again, like I said, start with the smallest prime numbers. Or if you know a big prime number that can go into the number, then go ahead and use that one. So here I have 190, so 19 obviously comes to mind because 19 is a prime factor. So we know that 190, this 190 is 19 times 10. Okay, so 380, I can write it as 2 times 19 times 10. So this is prime, 2 is prime, 19 is prime, but 10 is not prime. And then we say which prime numbers can go into 10, and that is 2 and 5. So this is 2 times 5. So 380, if I were to break it down into its prime factors, this is 2 times 19, and then instead of 10, I say 2 times 5. And we can condense this. This is 2. There's 1 2 here and another 2 here, so that is 2 squared. And usually we want to write them in ascending order, that is from the smallest one to the biggest one, even though it doesn't really matter the order you put them in, it just looks nice. So 380 as a product of its primes, this is 2 squared times 5 times 19. Now we have to find the highest common factor of 114 and 380. So to do this, since we've already worked with 380, we can also go through kind of the same thing, break down 114 into its prime factors, and then from there we should be able to see what the highest common factor is. So 114, so we know 2 can go in there. So 114 divided by 2, this is 57. Now 57, 3 can go into that, it's not a prime number. So this is 3 times 19. Okay, so you can see that I have 114. I can write this as 2 times 3 times 19. So this is 2 times 3 times 19. And then 380, if I write the expanded form of this is 2 times 2 times 5 times 19. So you can see they have 19 in common, and you have 1, 2 in common. That is a factor. So the highest common factor of 114 and 380 would be 2 times 19, which is equal to 38. Okay. Number 7, on a certain day, a shop sold 80% of 900 copies of Epukiro newspaper. Calculate the number of copies that were left in the shop. Okay, so very important with these word problems is you must understand the words that are used in the question. Read it correctly, make sure you understand what is being said. Now here we are told that they sold 80% of 900 copies. So that means there were 20% left. So the number or the percentage that was left is 20%. So you can work out what 80% of 900 is and then subtract from 900. That will tell you how many are left. Or you can go straight ahead and say, okay, I know that if I sold 80%, 20% is left. So I can just work out 20% of 900. So we're looking for 20% of 900. This 20% we can write as 20 over 100 multiplied by 900. We know how to work this out. This is 20 times 9, which is 180. So there were 180 copies that were left in the shop. Okay, number 8, Khalifa started exercising at 10:15 and finished at 11:05 on the same day. For how long was Khalifa exercising? Now, with this one here, you can use arithmetic to work it out, or you can do like a calculation if you look at an analog watch and try and figure out how many minutes she was exercising or how long she was exercising for. Okay, so the first way, like I said, is you can use basic arithmetic. So you have 11:05, and then this is the time that she finished. And then you are going to subtract the time that she started, he or she. I'm not sure if it's a boy or a girl's name. Okay, so this is time that they started. Okay, so 5 minus 5 is 0. Then here you have 0 minus 1. So we know that 0, when we're doing it this way, cannot, so you need to borrow. So doing that, you cancel. Okay. So it has 0 here, and with ordinary arithmetic, whenever you borrow, this would become a 10. But remember, here we're talking about time. So I'm borrowing an hour to give to the minutes, and we know that 1 hour is 60 minutes, so this becomes a 6. So I say 6 minus 1, this is 5, and then over here I have 0. So the answer is just 50 minutes. Okay, so I say there is a second way that you can use to think about this, is seeing that, okay, he or she started at 10:15, so an hour would be 11:15. Okay, so you can start at 10:15, and then if you go up until 11:15, this is 1 hour. Okay, but she didn't go up until 11:15. She went up to 11:05. So that means you need to subtract 10 minutes to get to 11:05, to get to 11:05. So it would have been an hour if she went to 11:15, but she didn't use 10 minutes. So you'll say 1 hour, which is 60 minutes, minus 10 minutes, and you would still get 50 minutes. So this is just an alternative way of working it out, and you can see that in either case you get the same answer. All right, number 9, work out 2 3/3 minus a quarter. Here, when it says show all your workings, usually you don't use a calculator. You should do it without a calculator. So 2 3/5 minus a quarter. First thing, with this mixed fraction, rewrite it as an improper fraction. The way to do it is you say 2 times 5 is 10, and then you add the number in the numerator. So 2 times 5 is 10, 10 plus 3 is 13, and this is over the denominator here. So I have 13/5, pardon me, and then I subtract 1/4. Now, very important, I see this mistake quite a lot when we give 2 fractions and I say subtract. A lot of people just say numerator minus numerator, denominator minus denominator, which is not correct. in order for you to add or subtract fractions, the denominators must be the same. So here you can see my denominator as 5, and for the second fraction, the denominator is 4. They are clearly not the same. So you first need to make the denominators the same. So I look for the lowest common multiple of 5 and 4, which is 20. So you say, what do I need to multiply the 5 by in order to make it 20? I need to multiply it by 4. And what do I need to multiply the 4 by in order to make it 20? It is 5. So here you'll have a 13 over 5. You're going to multiply this by 4 over 4. Remember that 4 over 4 is 1. And when I multiply anything by 1, it remains the same. It doesn't change. Like 100 times 1 is 100. 10 times 1 is still 10. It doesn't change. Okay, and then I'm subtracting 1 over 4 times 5 over 5. So multiplying of fractions, that's the one where you say numerator times numerator, denominator times denominator. So I'll say 13 times 4, this is 52. So I have 52 over 20. And then 1 times 5 is 5, and then 4 times 5, this is 20. And now when your fractions have the same denominator, you proceed to subtract the numerators. So here we'll say 52 minus 5, which is 47, over 20. Okay, then you can rewrite this as an improper fraction. We know that 20 goes into 47 2 times. There is a remainder of 7, and this 7 is over 20. So this is 2 and 7 over 20. Okay, then number 10, Oveni was given $3,511. She invests this amount in a local bank for 2 years at a rate of 4.5% per year. Compound interest, calculate the total amount that she received after 2 years. Now, as you know, with compound interest, there's this formula that we use. A is equal to P multiplied by 1 plus r over n to the power of nt. Now n, this is the number of times it is compounded in a year. So here it's just compounded once a year, so n will be 1. Sometimes it can happen that it's compounded monthly. So if it's compounded monthly, that means you will receive interest 12 times in a year. If it is compounded semi-annually, that means twice in a year, so your n will be 2. Now this one is just per year, that means our n is going to be equal to 1. Now t is the time. We have 2 years, so that's 2, and then our rate, it's given as a percentage, but you must always rewrite it as a decimal. So 4.5%, this is 4.5 over 100. That's what percent means. It means over 100. So this is equal to 0.045. Okay, and then our P, our principal, that's the amount that you start with, which is 3,500. So now I have everything I need. It's just a matter of substituting into my formula. So my P, this is 3,500. And I have 1. What is my R? 0.045. And then my N is 1 dividing by 1. Whether I write that or not doesn't really make a difference. And I have 1 times 2. And we know that 1 times 2 is just equal to 2. Okay, so this you would just type in on your calculator exactly the way I have it, and this should give you 3,822 and 09. Okay, so you can round this off to 10 cents because we don't have a 9 cents. So here I would write this because that is what the bank would do anyway. So this is $3,822.10. Okay, and again, that is simply because there is no 9 cents coin that you can give to anybody, but there is a 10 cents coin that you can provide. Okay, number 11, in the space provided, write each number in your calculation correct to one significant figure. So we have this sum here that we have to work out, but first convert each of these to one significant figure. So the first one, remember that a 0 before the decimal is insignificant. So our first significant figure is 4. Then you look at the number after the 4. This is a 7. It's greater than 5, so this 4 will become a 5. So 0.475 to one significant figure is 0.5. Then here the 3 is significant. You look at the number after the 3, it's a 4. So we would not round this up, and then all the digits after the 3 will become 0. So this will be 3,000. Then 9.892, the 9 is the first significant figure. You look at the number after that, or the digit after that, which is an 8. 8 is greater than 5, so this 9 will be rounded off and we will have 10. Then same thing over here. My first significant figure is 2. I look at the number after that, it's 4. 4 is less than 5, so all the digits after that will become 0. So I will then have 20. So this is how I write each of these numbers correct to one significant figure. Then use your answer in part A, the one that we did just now, to find the estimated value of this calculation. So this one where I wrote the numbers correct to one significant figure is definitely much easier to work out than this one. So you can simplify the numerator first, and then the denominator, and then finally the division. So numerator, I have 0.5 times 3,000. That's a half of 3,000. So I would then have 1,500 in the numerator. And then in the denominator, I have 10 plus 20. This is 30. Then you can see that the zeros will cancel. So that 0. Okay, my pen. So the 0 would cancel. So I have 150 divided by 3. This is equal to 50 because, sorry. So the 3 goes there once, into 15, it goes 5 times, and then the 0 there. So this is equal to 50. And you can always check if your answer is somewhat correct on the calculator. So this original fraction, the way it is given, type it in on your calculator, 0.475 times 3,400 divided by 9.892 plus 24.77. Okay, and the answer is 46.58340,304. And if I were to write that to one significant figure, the answer is going to be equal to 50. So you're sure that what you've done is correct. Okay, number 12, we're told that in a hospital in 2021, the ratio of the number of boys born to the number of girls born was 3:2. So that means for every 3 boys that were born, there were 2 girls that were born. Then in 2021, we have 180 baby boys that were born. Now we have to calculate the number of girls that were born also in 2021. So we'd write this ratio that we are given. So I'll write it like this. We have the ratio for boys to girls. Okay, and this ratio is 3 to 2. Okay, and now we are told that there's 180 boys that were born, and since we don't know how many girls were born, we can write this as X. And now solving this ratio, you can say 180 divided by 3. So this 180 here, you divide it by the 3 over there, and then you do the same thing on the right. This is equal to X divided by 2. And then to solve for X, you just simply multiply by 2 on both sides. So these 2 will cancel. So here I have 2 times 180 divided by 3. This is equal to 120. So I have 120 is equal to X. That means that X is equal to 120. And X represents girls. So there were 120 baby girls born at that hospital in 2021. Number 13, Jürgen went to visit his grandmother in Germany. He exchanged 5,500 Namibian dollars to euros upon arrival. Now we're given the exchange rate, which is 1 euro is equal to $19.60. Calculate the amount in euros that he refused. So this is similar to the previous question in that you can use ratios to solve it. So you can write this as Namibian dollars to euros. Okay, and we are told that 1 Namibian dollar, sorry, not 1 Namibian dollar actually, so it's 1 euro. This is equivalent to 19.60 Namibian dollars. And he had 5,500 Namibian dollars, so at 5,500 Namibian dollars, and we want to work out how many euros that is equivalent to, so we can put an X. So we can now convert this ratio to fractions. So we say 5,500 over 19.60. We don't need to put the 0 because it comes after a decimal. This is equal to X over 1. Now we know that X over 1 is just equal to X. So we can work out the one on the left. So 5,500 divided by 19.6. This is 280. So 280.61. Only writing it to 2 decimal places because currency, usually write it to 2 decimal places. This is X. And I don't think there's a 1 cent euro coin. I'm not sure. So in euros, this would be 280.60. Okay, then number 14, convert 108 kilometers per hour to meters per second. So 180, sorry, not 180, 108 kilometers per hour. So what you do is you rewrite this as a fraction. So this is 108 kilometers per hour means per 1 hour. So you have 108 kilometers for every 1 hour. That's what 108 kilometers per hour means. And then what you do is you'll convert the kilometers to meters and convert the hour to seconds. So converting from kilometers to meters is very easy. This is just a matter of multiplying by 1,000. But then converting from hours to seconds, you would have to first convert to minutes. And then from minutes, you can convert to seconds. And then converting from hours to minutes, you multiply by 60. And then converting from minutes to seconds, you multiply by 60. Okay, so our fraction here 108 over 1. The numerator, I would multiply it by 1,000. That means I've converted it to meters now. And then the denominator, I would multiply it by 60. That means converting it to minutes. Then multiply by 60 again. Then it's in seconds. So this would then give us 108,000 over 3,600. And we always want to write this to 2 decimal places, I believe. So the instructions are there on the front page. Okay, if the degree of accuracy is not specified in the question, give the answer to 3 significant figures. Okay, so we should give this to 3 significant figures. So you would type this in on your calculator. This is actually an exact value, so this is 30 meters per second. So it'll be 30 meters over 1 second. So that is 30 meters per second. Right, number 15, we are told that the scale on a map is 1 to 280,000. Then a road is 4.8 centimeters on the map. Now we want to calculate the actual length of the road in kilometers. So 1 to 280,000. So this is 1 centimeter on the map represents 280,000 centimeters on the ground, so in reality. So this is ratios. So I can just erase that. So I have 1 to 280,000. So I want to find out what is 4.8 equivalent to on the ground. And since I don't know what it is equal to, I'm going to put x. So we solved 2 questions already involving ratios. So we'd write this as 4.8 divided by 1. This is equal to x over 280,000. And then we can cross multiply. We get 4.8 times 280,000 is equal to x. Which you just type on your calculator. This gives 1,344,000. Okay, is equal to x. And remember that x is in centimeters because this is in centimeters. So we have 1,344,000 centimeters. Right, and then we have to convert the centimeters to kilometers. So first, converting from centimeters to meters, you would to meters, you would divide by 100, and then from meters to kilometers, you would divide by 1,000, or you could just divide by 100,000 straight away. So since the number is already there on my calculator, I have 1,344,000. I'll divide it by 100. That gives me 13,440 meters. So here I have, let me write it over here in meters. This gives me 13,444 meters. And then converting to kilometers, you just divide by 1,000. This is a 13.440 kilometers. Okay, so this is an exact value. So we have 13.440 4 kilometers. The 0 does not need to be included. Number 16 says that a total of 950 Ochitati students entered a quiz competition in 2021. This was an increase of 25% on the 2019 entry. Calculate the number of students who entered this quiz competition in 2019. Okay, again, with word problems, extremely important that you understand the words that are given in the question. Okay, so understand what is being asked and what is being stated. So to do that, we know that there was an X number of students that entered the competition in 2019. We don't know how many they are, but we know that it is 25. In 2021, it went up by 25%. So that means in 2021, instead of having the same number of X, we had X plus 25% of X. So that means we had 125% of X, because it went up by 25%, so that's 125%. And now we know that in 2021, we had 950. So all this, you don't need to actually write it the way I did over here. Basically, what I'm doing is just breaking down what is written in words and rewriting it in a mathematical way. So I have 125% of X. This is equal to 950. And then we know that 125%, this means 125 over 100 of, we can write it as times X. This is equal to 950. Then would multiply by 100 on both sides and divide by 125. So X, this is equal to 950. Multiply by 100 and divide by 125. So this you just type in on your calculator. This gives 760. So there were 760 students that entered the competition or the quiz rather, in 2019. And you can always check that what you did is correct, not that you should necessarily write this down. This is something you can do on your calculator. You can find 25% of 760. This is 190. And then you say 190 plus 760. And you will see that the answer is 950. So again, this is not something that you should necessarily write on the paper. I'm just showing you a way that you can check and see that what you have done is in fact correct. Number 17, we have solve 10x is equal to 8. So 10x is equal to 8. So remember that 10x means 10 times x. So to get rid of this 10, you'll divide by 10 on both sides. Remember, what you do on one side, you must always do on the other side. Then these two will cancel. I'll have x is equal to 8 over 10. This is 4 over 5. Or 0.8. So you can write 4 over 5, that is the fraction in its simplest form, or it's 0.8. Number 18, expand. We have 6 times 2a minus 5. Now the way you expand is this number outside should multiply all the terms inside the bracket. So you have 6 times 2a, and then, and then also 6 times negative 5a. So you'll have 6 times 2a, this is 12a, and then 6 times -5, that is negative because this is positive times negative is negative, and then 6 times 5 is 30. So my answer is 12a minus 30. Number 19, simplify 4f minus 2g plus 8f minus 7g. Just a matter of collecting the like terms. So if I can just rewrite it, I have 4f minus 2g plus 8f minus 7g. So you collect the terms with f and the terms with g. So I have 4f here, you circle it, and then 8f, you should always circle the sign in front of the term because they go together. So I can write them next to each other. So I have 4f plus 8f, and then the same thing, these two are like terms. The sign in front of the term is part of the term. So then I have negative 2g minus 7g. So 4f plus 8f, this is 12f, and then negative 2g minus 7g, this is negative 9g. So our final answer here is 12f minus 9g. Then number 20, we have to rewrite log 2x cubed as a separate logarithm. So keep in mind your laws of logarithms. So we would separate this as log of 2. Remember, the 2 and the x to the power of 3 are multiplying. So we write that as a sum. Then one of our laws says that if our argument has an exponent, the exponent can come down. So this is log based, log of 2 plus 3 times log 3. So I'll answer log 2 plus 3. Sorry, I don't know why I wrote x here. I wrote 3, there should be x. So this is log x. Now, very common mistake I see that from here straight away, some students take this 3 and bring it down. That is not correct. The only time you would do that is if the 2x was in brackets. Here, the cube belongs to the x, so you need to split it up first like this, and then you can bring that down. Number 21, we have 3p minus 10 is greater than p plus 2. We have to solve this inequality. Greater than or equal to 7p plus 2. So we'd solve this pretty much the same way we solve an equation, that the terms with p on one side of the inequality, and then those without p on the other side of the inequality. So I would subtract 7p on both sides. So I have 3p minus 7p minus 10, this is greater than or equal to, these two will cancel, 2, and then I would add 10 on both sides. Now, of course, you can do both of these, so that's this one and that one, subtracting 7p and adding 10 at the same time. So I'm just emphasizing the working that I have done. So these two will cancel, and then I have 3p minus 7p, this is greater than or equal to 2 plus 10. And whenever you add or subtract anything on either side, on both sides of the inequality, it does not change direction. Whether you're adding or subtracting, the inequality does not change. Then on the left hand side, I have 3p minus 7p, this is minus 4p. And then 2 plus 10 is 12. Then I would divide by -4 on both sides. Now, very important, whenever you divide by a negative number on both sides of the inequality, this inequality must change the direction that it is facing. So if you divide by negative number, or you multiply by negative number on both sides, then the inequality must change the direction that it is facing. The negative 4s will cancel. So I'll be left with P, and then 12 divided by negative 4 is negative 3. So my answer is that P is less than or equal to negative 3. Number 22, the first 4 terms in a sequence are negative 3, 5, 13, and 21. So this looks like an arithmetic sequence. So to check, you take any 2 consecutive numbers, that means they follow each other, and then you say the one on the right minus the one on the left. So I would say 5 minus negative 3, this is 8, 13 minus 8, minus 5, sorry, this is 8, and then 21 minus 13, this is also 8. So you can see that there is a common difference, and that tells us that this is in fact an arithmetic progression or an arithmetic sequence. Now the formula for the nth term of the sequence is given like this: an, this is equal to a1 plus n minus 1 times d. a1, this is, sorry, a1, this is the first term in the sequence, and that one we can just observe is negative 3. So here my a1 is negative 3. And then d, this is the common difference, which we just worked out as 8. So now we just substitute. We say an, this is a1, which is negative 3, plus n minus 1 times the common difference, which is 8. Now this 8 will multiply inside the bracket like that. So we have an, this is negative 3, 8 times n is 8n, and then 8 times negative 1 is negative 8. Then negative 3 and negative 8, you can combine them. So we'll have negative 8, sorry, negative 3 minus 8, that's a negative 11, plus 8n. Okay. Number 23. We're given 2 functions. F of x is equal to 3 minus 3x, and g of x is equal to x squared. A says find the value of g of negative 3. That just means in the function g, wherever you have x, replace the x with negative 3 and solve. So g of negative 3, this x, I will replace it with negative 3. So I have negative 3 squared, which is negative 3 times negative 3, and the answer is positive 9. Then f inverse of x, so our function f of x, this is 3 minus 3x. What you do to find f inverse is this f, you make it y. Excuse me. Then you interchange the x and the y. So that means your y will become an x, and then the x will become a y. And then from here, you just change the subject of the formula to y. So I can subtract 3 on both sides. So I have x minus 3 is equal to negative 3y. Then I can divide by negative 3. So I have y is equal to x minus 3 over negative 3. And here you can write it as x over negative 3 and plus negative 3 over negative 3. This is negative x over 3 plus 1. You can simplify it like that, or you can rewrite this as 3 minus x over 3. So either one of these is fine. That's your y, and you can, this is my f inverse of x. So f inverse of x, this is 3 minus x over 3, or it's the same as x minus 3 over negative 3. Then g of f of x. Now g of f of x, here I believe they mean the composition of f and g. So I just need to write down what g of x is. G of x, this is x squared, and f of x, this is 3 minus 3x. Now g of f of x, this means that instead of putting x into g, you are going to put f of x. So this is g of 3 minus 3x. So we already worked out g of negative 3, and we say the way to work that out is simply to replace the x here with 3 minus x. So this is 3 minus 3x squared. So g of f of x, this is 3 minus 3x squared. Of course, you can expand this the way you do it. You have 3 minus 3x. Remember that squared means you multiply something by itself, and then you multiply 3 times 3 is 9. 3 times negative 3x is minus 9x. Minus 3x times 3 is minus 9x. And then negative 3x times negative 3x, this is 9x squared. So this is also equal to 9 minus 18x plus 9x squared. Number 24, factorize completely. We have x squared minus 16x. You can see that x is a common factor, so we can take the x out. X squared divided by x is x. And then negative 16x divided by x is negative 16. And inside the brackets, there isn't anything else you can factor out. So this is factorized completely. Then B, this is a quadratic trinomial. You want to factorize the quadratic trinomial. You look at this 39, you look for two numbers that when you multiply them, the answer is 39. And when you add them, the answer is negative 16. So that is negative 13 and negative 3. So you would break down this number here, this term here in the middle as negative 13 and negative 3. So you have x squared minus 13x minus 3x plus 39. So see, negative 13x minus 3x is equal to negative 16. Then you look at the first two terms. What do they have in common? X. You say x squared divided by x is x. Negative 13x divided by x is negative 13. And then the second bracket, what do they have in common? Negative 3. Then negative 3x divided by 3 is positive x. And then positive 39 divided by negative 3 that you took out, this is negative 13. Now you can see that these two brackets are the same, so you can proceed and factorize again. This is x minus 3, so this x and that minus 3, and then this bracket here that they have in common, x minus 13. So when it's factorized completely, I have x minus 3 times x minus 13. And of course, it doesn't matter if you have x minus 13 and x minus 3. Because these two are multiplying, the order that you write them in does not matter. Okay, number 25, the graph shows the speed of Wesley in a cycling race. So you can see that this is a speed time graph. Now we're asked to calculate the total distance traveled by Wesley over 3 hours. Now, one thing that you should take note of and remember is that the total distance this is simply given by the area under a speed time graph. So if you can work out this area here, I'm going to shade it. So if you can work out this area here, that will give you the distance that he traveled over the 3 hours. Now this shape that we're given here is trapezium. So we can work out the area using the formula for the area of a trapezium. But if you don't remember that formula, what you can do is break up this shape into 3. So you can see I have 2 triangles. There's a triangle here. This is one triangle. There's another triangle here, this one here, and then this area over here, that is a rectangle. So don't panic in the exam if you can't remember the formula for the area of a trapezium. But the formula is not that difficult, so we use the formula. So the area, this is equal to a half, then A plus B times the height. Now A and B, these are the 2 parallel sides. So take note that A and B are the parallel sides. And H, this is the perpendicular height. Okay, so we just need to figure out what is A, what is B, and then we multiply that by the perpendicular height. Now our A, can say the A at the bottom over here, this is 3, and then B at the top. So you can see it starts at 1 and then goes to 2. So you just say 2 minus 1. So at the bottom here, we have 3. At the top here, because those are the 2 parallel sides, we have 1. And then our perpendicular height starts from the top and goes all the way down. So that is 30. So A, this is 3, B is 1, and the perpendicular height is 30. So it's just a matter of substituting into our formula. So this is a half. Our A, we said, is 3, 1, and then we multiply this by 30. So exactly the way it is here on the calculator, you can type it in and you will get an answer of 60. So the area under the graph is 60, and we know that that translates to 60 kilometers. Okay, so you can check and do it the other way. Remember I said you have 2 triangles. There's one triangle here and another triangle here and a rectangle in the middle. Work out the area of all 3 of them, add them all together. You will see that you will also get 60 as your answer. Okay, number 26, it is given that m is directly proportional to the square root of n. Find the value of s and the value of t. Now, when we are given that 2 terms are directly proportional, proportional. Now, directly proportional, what does this mean? It means when one goes up, the other one also goes up. So here we are told that M is directly proportional. We use the symbol alpha. It is directly proportional to the square root of n. So the square root of n. So when I write it like this, this reads as m is directly proportional to the square root of n. So if m goes up, then the square root of n also goes up. If m goes down, the square root of n also goes down. Now, when we have two terms that are directly proportional, it means that one is a scalar multiple of the other, okay? And from there, we can rewrite this as an equation and not just an expression like this. And this, we can rewrite that m is equal to some constant k multiplied by the square root of n. So this is what we call the constant of proportionality. So whenever you have any two terms that are directly proportional, you can write the first one is equal to some constant of proportionality multiplied by the other one that it is directly proportional to. So what you always want to do is you want to work out this k, and then that will help you figure out what s and t are. Okay, so you use values that are known. We know that when n is 4, m is 3. So we'll substitute them over here. So m is 3, so we say 3 is equal to some constant of proportionality k that we have to figure out, multiplied by the square root of n. N is 4. Okay, so we know that the square root of 4 is 2, so we have 3 is equal to k times 2, and then we can divide by 2 on both sides, and we end up with k is equal to 3 over 2. So now that we know our constant of proportionality, we can rewrite this expression here without the k. So we can say that m is equal to our constant of proportionality, which is 3 over 2, multiplied by the square root of n. And then we'll use this equation here to solve for s and t. So let's start with this first one here. Here we're given the value of n, so n is equal to 9. So we'll substitute it there and then solve for s. So when n is 9, m is s. So we have s is equal to 3 over 2 multiplied by the square root of n, which is 9. Now the square root of 9, that's 3. This you can just type in on your calculator, but you don't need a calculator to work this out because these are fairly small numbers. So this is 9 over 2. So that is our s. S is equal to 9 over 2. And then we do the same thing to work out t. We are going to replace n in this equation. So this is our equation that we will use, that we are using. So we have n is t and m is 27. So where we have m, we put 27. This is equal to 3 over 2 is our constant of proportionality. It is constant, that means it doesn't change. And then we multiply by the square root of n. What is our n? N is t. Okay, so we want square root of t to be alone, so we'll multiply by 2 on both sides and then divide by 3, or just multiply by 2 over 3 on both sides, multiply by 2 over 3 on both sides. You can see that the 2's cancel, the 3's cancel, and then we are left with, on the right hand side, we have 2 over 3 times 27. This is equal to 18. So we have 18 is equal to the square root of t, or the square root of t is equal to 18. Then to get rid of the square root, what you need to do is you need to square both sides. So this squared and that squared. So the square root, and the square will cancel. We'll be left with t, and then 18 squared is equal to 324. So this t is equal to 324. Okay, next question. I'm going to make this a little bit smaller so we can see the whole graph. Let's see. Okay, number 27. By shading the unwanted region, find and label the region R which satisfies the following inequalities. Y is greater than or equal to X, and X plus Y is less than or equal to 7. Now we have two lines here that are drawn. First, we need to identify them. Now, if you look at this first line that goes from the origin to this point 7, 7, if you pick any point on the line, like you can see here, I have 1, 1, I have 2, 2. This is the line Y is equal to X. And this is the line Y is equal to X. Now you want to shade off the unwanted region. So Y is greater than X is part of R. So what you don't want, or the unwanted region, is when Y is less than X. So it's going to be either above this line or below this line, because this line is when Y is equal to X. Now you want Y to be greater than X, so that means the unwanted is when Y is less than X. Now, if you're not sure which one to shade, all you need to do is pick any point that is either above or below. And then if that point satisfies what you are looking for, then that is part of the region you're looking for. Or if that point does not satisfy, then everything in the region where that point is the unwanted region. Okay, so that may be a little bit confusing, but it's actually not that difficult. So our line here tells us when Y is equal to X. So what I do is I'm going to pick a point below the line. Let me see, which point will I pick? A bit small. Just make it a tiny bit bigger. Okay, so I have a point here. This is 2, 1. I hope I've labeled that correctly. Okay, so that's the point I'm picking. That is my test point. So let me label it. This is 2, 1. And this is your test point, and your test point is going to help you decide if everything below this line Y is equal to X is part of your wanted or unwanted region. So you have your point here. So this is your test point. 2, 1. Then you go back to what R represents. R represents Y is greater than or equal to X. So you look at this test point that you have. The X coordinate is 2. The Y coordinate is 1. So you ask yourself, in this case, is Y greater than X? Y is 1. X is 2. So here, Y is not greater than X, but we want Y to be greater than or equal to X. So this point is in the unwanted region. So it's in the unwanted region. So that means every other point I pick below the line Y is equal to X is in the unwanted region, and we are going to shade off the unwanted region. So we're going to shade this off. Okay, you may be wondering, okay, so you'll do a better job than I'm doing of shading, because I'm using an electronic, but shade it off the way your teacher showed you how to shade it. It's just a little bit trickier with my pen. Okay, so you may be wondering what would have happened if I had picked a point above the line. Would I still end up shading the area below the line y is equal to x? And the answer is yes. So what I do is I pick any point above. So I'm double testing this line, which you don't need to do, but I'm just trying to emphasize what you need to do. Okay, so let's say I pick a point that is above the line. So remember, this is a line y is equal to x. So I pick, let me pick this point here. 0, 1. Okay, so I'm double testing. So I've picked the point 0, 1. Now my x value is 0, my y value is 1. Remember, what you want is that y must be greater than or equal to x. So I look at my x and y values here. X is 0, y is 1. And I ask myself, with this point, is y greater than or equal to x? And the answer is yes. So the region above the line is my wanted region. So I'm not going to shade the region above the line. So I would still end up shading off the region below the line. Okay, so it doesn't matter whether you pick a point above the line or below the line. If you test them correctly, you will always end up shading the unwanted region. Okay, then the second part that we are supposed to use to shade out our second inequality is that x plus y is less than or equal to 7. Now this line, the second line that we are given, this is actually the line x plus y is equal to 7. Because if I look at this point, this is 0, 7. When I add them together, I have 7. This point over here is 1, 6. 1 plus 6 is 7. This point here is 2, 5. When I add them together, I get 7. So I'm going to test the region above or below to see which one I need to shade out. Again, remember, all you need is a test point, and then if the point satisfies what you're looking for, you shade the opposite of where that point is. Okay, so let's pick a point. So what do we want? We want x plus y to be less than 7. So I'm going to pick, this is my line, I'm going to pick an easy point, that's this one here. So my test point is the point 0, 4. So my x coordinate is 0, my y coordinate is 4. So remember, I want x plus y to be less than or equal to 7. So I'm going to add the x coordinate to the y coordinate, and if the answer is less than 7, that is the region that I want. So I'm going to say 0 plus 4, this is 4. 4 is definitely less than 7, so every point below this line satisfies what I'm looking for. That means every point above does not satisfy, it is unwanted, so I'm going to shade off every point above the line. Okay, so you can see shading, I'm shading above this line. So shade it the way you learned how to do it in class, and this is what you have. So you can see that this region here is the only unshaded region, and you label it nicely. This is R that we're looking for. Okay, number 28. The exterior angle of a regular polygon is 24 degrees. Calculate the number of sides of this polygon. Now here you just need to remember the formula that the exterior angle is equal to 360 divided by the number of sides of the polygon. So this is the general formula, just keep it in mind, and you will always be able to work out a question like this. Okay, so our exterior angle in this case, this is 24. This is equal to 360, and then we'll call the number of sides n. So cross multiplying, we have 24n is equal to 360, then divide both sides by n. by 24, get n is equal to 360 divided by, what am I doing? Divided by 24. This you can just type in on your calculator. This is 15. So that means this polygon has 15 sides. Okay, number 29, describe fully a single transformation that maps F1 onto F2. So F1 onto F2, so you can see that the size has not changed, so it's definitely not an enlargement. It is facing a different direction, so already rotation should come to mind. Okay, so rotation comes to mind. And you can see that this point over here is the same for F1 and F2. So that is the point that has not changed. And the point that doesn't change is your center of rotation. So we say that this is a rotation. So with the rotation, we need to provide three things. Or with the transformation, we have to provide that it is a rotation, then our center of rotation. So the center is, read the coordinates, this is 3, 4. And we need to state the direction or the angle. So we can say it is clockwise, anti-clockwise, and so on. So it went from here, so it went in that direction. So this is 90 degrees. You can even see the angle here. This is 90 degrees, and this is clockwise. All right. Then enlarge the letter N by a scale factor 3 about the center 0, 0. So this one is one that you would have to use a ruler. What you would do is you take a ruler from the origin to each point of the letter N, and then take that same line, measure it, whether it's 2 or 3 centimeters, and then you say 2 centimeters times our scale factor, which is 3, and then you'd measure 6 centimeters, plot the point, and then transform like that. So I'm going to try and do this over here. It's a little bit tricky because I don't have a ruler with my tools, but let's see if I can do it. Otherwise, I will just explain it and hopefully you'd get what it is you need to do. Okay, so I've drawn that line. Now what you need to do is take this line and then 3 times the same line. So that's 1. Okay, so that's 3. So you can see I have a point over there. Then I do the same thing for each point. So you can see that if you count the number of squares that make up any side, the new one that you get is 3 times the length of the other one. So, but that's basically how you should do it. Okay, 30, a solid glass shape is formed from a hemisphere and a cylinder. The hemisphere has a radius of 3 centimeters and the cylinder has a height of 5 centimeters. Calculate the total volume of the glass shape. So to work out this volume here, you just need to find the volume of this cylinder. So the volume of the cylinder and this hemisphere. Okay, so hemi means a half of a sphere. So the total volume, this will be the volume of the cylinder, which is given by pi r squared times the height. And the volume of the hemisphere is half times the volume of the sphere. So it's half times 4/3 pi r cubed. Okay, so our r is 3, our h is 5, and we have everything that we need. So this is just a matter of substituting. So this is pi multiplied by our radius, which is 3 squared, times our height, which is 5, and then we have a half times 4/3 times pi times the radius cubed, which is 3 cubed. So this you would just type in on your calculator. And my calculator gives me 63 pi. Okay, so we're told to either use pi on our calculator or 3.142. I use the one on my calculator. Then in decimal, this is 197.9203372. And leaving it to 3 significant figures, this is 198 centimeters cubed. Okay, 31, it is given that P is equal to this vector here, -1, 2, and Q is this vector here, 3, 4. So we have to calculate P plus Q. With column vectors, you just add the corresponding components. So you have -1, 2, and 3, 4. So this is -1 plus 3, and then 2 plus 4. So you add the corresponding components. This is 2, 6. So the answer is 2, 6. Then we have to find the absolute value or the norm of Q. That is just the distance. And the formula for this is very simple. It's just the square root of the I component squared plus the j component squared. Okay, so this you do on your calculator. This is equal to 5. All right, number B, still on vectors. We are told that in the triangle ODE, OD, here the vector from O to D is D, there it is, and the vector from O to E is just E. Then F is a point on DE such that DF is 2/3 DE. So this is 2/3 of DE, and then naturally that means FE is 1/3 of DE. Okay, because 2/3 and 1/3 should add up to the entire DE. Okay, so calculate in terms of D and E, the vector DE. Okay, so we want to work out DE. E. Now with these vectors, the way to get it is pretty simple. All you need to do is imagine that you are at the starting point D and you want to get to E. That's it. So if I'm at D here and I want to get to E, you obviously have to use paths whose vectors you know. So if I'm at D and I want to get to E, what I can do is I can go from D to O, and then from O, I will go to E, and that means I've gone from D to E. Now, DO is in the opposite direction of OD, so that means it is negative D, and then OE is just E, so I'm underlining them to show that they are vectors, but you can write it without the underlining, or sometimes you'll see that there's a hat because I can't really bolden it the way they have done. So this is minus D, maybe I should try boldening it, plus E, if I can bolden it. Okay, so that's the answer. Okay, or you can write it as E minus D, same thing. Okay, then number 2, the position vector of F. Now the position vector just means find OF. That is what the position vector of F means. So again, imagine you're at O and you want to get to F. So if I'm at O and I want to get to F, I can go from O to D, and then I can go from D to F. But remember, in the question, we're told that DF is 2/3 of DE. So this is OD plus 2/3 of DE. Okay, and here in the previous question, I worked out what DE is. It's minus D plus E, so I can substitute there and I have everything I need. So this is OD. What is OD? It is the vector D, and 2/3 of DE, you must put it in brackets. This is negative D plus E. Okay, and this 2/3 will multiply everything in. I'm running out of space. This is D minus 2/3 D plus 2/3 E. So this 2/3 must multiply the negative D, and it must also multiply that. Then D minus 2/3 D, this will give me 1/3 D. So it's 1/3, and then D, I'm just going to make it bold, and then the 2/3. That is my answer. Okay, number 32. Back. Number 32 says Jerry has a bag containing red, green, and orange balls. The table shows the probabilities of choosing a red or a green ball. Complete the table to find the probability that Jerry chooses an orange ball. Now, because there's only 3 options, either a red, green, or orange ball, it means these probabilities, 0.3, 0.25, and the probability of choosing an orange ball should add up to 1. So to find out what the probability of choosing an orange ball is, this is from A, probability of choosing an orange ball, all I need to say is 1 minus the sum of the probability of choosing a red ball with the probability of choosing orange ball. So this is 1 minus 0.55, which is equal to 0.45. So this is 0.45. Then B says find the probability that Jerry chooses a ball that is not orange. So the probability that he chooses a ball that is not orange. This is just 1 minus the probability that he chooses a ball that is orange. So this is 1 minus 0.45, which is 0.55. So this is 0.55. Okay, number 33, the mass of each of 200 tea bags was checked by an inspector in a Vintage factory. The results are shown in a cumulative frequency curve. Okay, so this is our cumulative frequency curve. Now we want to use the curve to find the median mass. Okay, so to find the median mass, all you need to do is, you can see, okay, I have 200 tea bags. The median is exactly halfway. So halfway between 0 and 200 is 100. So what you would do is you would take your ruler and then you would start here at 200, which is halfway because median means half. And then you would draw a line until it touches your curve. Then you would take your ruler and straight from the point where it touches the curve, you go straight down and draw another line, and that line over there, and then this will give you the median mass. So if I read this, this is 3.3. Okay, so let me write that down. This is 3.3, and this is 3.32, 3.34, 3.36. This point here will be 3.38. Okay, so you need to show these lines again because everything is black. It's not so clear, but we want to see these lines from here. So the median mass is 3.38 grams. And then to find the interquartile range, what you need to do is work out the lower quartile and the upper quartile, and then what you do is you subtract. Okay. Right, so you need to work out what a quarter of 200 is and what 3/4 of 200 is, and then you do the same thing we did with the median over here. So here, maybe just to show what I did, we said half or halfway. We would say 200 times a half, and then that gave us 100, which we plotted on the graph. So then a quarter times 200. This is 50. And then we also need 3/4 of the way. This is 150. Okay. All right. So we go back to our graph, and what you're going to do is do this with a ruler. Then at 50, you draw a straight line until it touches the graph. Obviously, I don't have a ruler here, and I don't like using this line here, so you need to use a ruler. So this is where it touches the graph, and then from there you go straight down. Okay, so looking at this, you would go straight down. It's just that when I do it the other way, it highlights this graph and I can't draw it properly. Okay, so because it's halfway, it's not exactly here or there, you would have to make an estimate. So this point here, that point is 3.2, and then there's 2, 4, and then 5. Okay, so I would say that's what it is. And then at 150, you do the same thing. You would draw a straight line using a ruler. So you draw a straight line until your straight line touches the graph at this point, and then you go straight down with a ruler. Again, I'm only doing it like that because I don't have a ruler, and using this tool is just taking me too long, but you need to use a ruler. Okay, so this one is nicely on the point. So this is over here. We have 3.5. So this point here would be 3.52 grams. Okay, so I have my 2 quartile values. So the interquartile range, the IQR, this is the 3rd quartile, so it's 3.52 grams minus the lower quartile, 3.25 grams. This you can do on your calculator, but you don't need to. And I get 0.27. So my answer is 0.27 grams. That is the interquartile range. Okay, and that's it. We are done with the exam paper. So you can see it didn't take us too long. The video is long because obviously I'm explaining stuff and writing things using my computer, which is definitely taking longer than on paper. So this is a paper that within 2 hours, definitely you have more than enough time to finish and make sure that you can check whether your answers are correct.